Welcome back to The Electronics Inside, the show where we tear down tools, toys and appliances just to find out what's inside. I'm David, and hopefully the presence of the overhead camera in shot tells you that this episode we're tearing down something small, specifically the 42mm Generation 3 Apple Watch. Or a former one at least. So this 42mm Series 3 Apple Watch has actually been sent to me by a viewer who damaged the screen or the digitizer. I think just the digitizer, so the touch sensitive layer over the top of the screen, and decided it was impracticable to replace it. So they were happy to send it over to me to see what's inside. I believe it still functions. Oh, it needs charging. That's a shame. But I think it's kept the time. No. Just needs charging now. So it probably needed a battery replacement as well as a replacement digitizer. Obviously the damage around the top, we're going to have to be careful of. That is glass. I've gloves and glasses so we can start tearing this down, hopefully as safely as we can. Now with this, you start by lifting the screen and digitizer assembly up, which means of course I've got to heat it to soften all the adhesives that make it waterproof, which means heat, sharp blades, glass. It's going to be a fun one. Let's get started. Okay, so I have knives, spudgers, pries, caps on tape, seal the glass in, glasses and gloves. Let's kit up and carry on. This probably seems really over the top, but I really don't want to get glass in my fingers. Less so my eyes. I'm going to use the caps on tape to sort of seal the broken glass in, just in case it shatters and falls to pieces. I learnt recently, you know, sort of spacecraft and satellites always look like they're sort of wrapped in gold foil blankets. Apparently it's not. The sort of composite material that the insulation's made out of actually has caps on tape in it, or the same material as caps on tape anyway. So technically that gold colour of spacecraft is basically capped on tape. Who knew? Okay, hot air rework station set as low as it will go. Blade at the ready to pry it open. Gloves on. Let's get some gentle heat going. So this has also got like a huge block of aluminium that the back is machined out of. That's going to act as like a thermal mass, so we kind of have to warm that up too. So I'm actually going to sort of heat the back as well. There we go. See where the corner of that glass is broken. Actually it's still stuck on, so I might give that a bit more heat. See if I can work that loose rather than leaving nice big jagged bits of glass on the frame. Okay, we are in. Though I'm not 100% convinced we got all the glass out. Let me clean that up before I dispense with the PPE. Ooh, the bit that I sort of associated with the glue has actually got like a connector running back to the board on it, so I can't actually run that all the way off. It's frustrating because I was hoping that was going to sort of clear all the glass for me. Okay, that's kind of the worst of it, or at least the scary bit. So now we can carry on looking at this slightly more sensibly. Kind of shocked at how much is actually adhered to the back of the screen. Ooh, so got a little sticker holding down zero insertion force connectors. So screen and digitizer as one module, 3 separate connectors with drivers on board. Very proud Apple marketing even inside the device. Got the Taptic engine. Can anybody that knows actually clarify this? Am I imagining things, or is a Taptic engine just vibration feedback? There is nothing more specific about it than that, is it? Just gently teasing that battery up. Connector is under the Taptic engine, so that has got to come out. Very strange little 3-lobe screws. If I've got something that will actually open that. So that is a 1.31 watt-hour battery, which is tiny. Actually pretty impressive they managed to get that much useful work out of such a tiny battery. Oh, there you go. That bit that sort of ran round with the glue has come off from the adjacent glue is separating from that ring. But what was this ring? I'm just having a look at how this crown works, because the crown is actually a really nice little piece of kit, and I can't see any obvious thing here, like a continuous motion potentiometer or anything. I wonder if that's actually got a magnet on the end of it and it's using a Hall effect sensor to get rotation. It looks like a tactile dome right at the back here that's responding to the actual presses, but the rotation I can't quite see yet. There are so many screws in this tiny thing. Do you know what? Actually, this configuration of sort of screws on the side frame is very reminiscent of the iPhone 3G we did. Just like where all the buttons were held on the side of the machined stainless frame. Really reminiscent of how this is assembled. Taptic engine. It's like the biggest single use of space in here is the vibration motor. Again, it's just that weird thing about moving parts. They need so much more physical space than everything else. Right. I think I've now got all the screws out of this. Also, I have just altered the exposure on the overhead camera to try and get a better view in there. It was just... It's so tiny and it's all black silk screens and stickers. It was really hard to see anything. So, sorry if the quality is less than stellar, but hopefully you can actually see the components to some useful standard anyway. So, we'll go with it. Hopefully... we are now in a good place where most of this will lift out. On the bottom strap here, there's actually a secret port behind where the strap plugs in, and there's a ribbon connector going to that, and I've undone the screws surrounding it, but it still doesn't want to budge, and I wonder if that's sort of adhered on for waterproofing. Okay, I'm actually struggling to remove the crown, because there is something underneath the crown, or at least from this point of view, that looks like... honestly kind of looks like an optical sensor, but I'm not going to get carried away guessing what it is. But it sort of points at the inside of the crown and it looks like a textured wheel. But at the end there are two parallel surfaces machined into it. And I kind of wonder if I can get hold of those with some tweezers or some flat nose pliers and then unscrew it from the outside. Maybe that wheel will separate from the outside crown and I can get them apart and get the whole thing out without damaging it permanently. What you're looking at here in a really macro scale, on the outside, this side, that's my finger for reference, is the crown. And on the inside, you see you've got that sort of textured wheel, but right on the end of the shaft, and just there, you can see sort of that shiny face. And if I get it to that position, you can see that's actually two vertical machine faces, so they're flat, so I should be able to grab hold of those. And then I'm hoping if I hold on to that and then unscrew that, I don't want to grab the whole thing because the texture on that shaft might be significant. So slight change of plans. So that's still the inside of the crown, you can see it turning. However, underneath is the sensor that I want to get out. Just there. And having had a good look at it under the microscope, there it comes. So that now frees up the insides. Here we have all the pieces that make up the watch. This random thing that sort of sat on the bezel behind the glue on the glass is actually the force feedback, what do they call it, spatial touch, 3D touch thing. So that was basically a pressure sensor to measure how much force was being pressed on the glass. So this part is now sort of the bezel, the case. At the back, bonded to the alley, you've got all the biometric sensors, so they're heart rate, and they're mostly optical on this version. I don't think you had sort of the inductive ones until later versions. It's interesting that this little coil around here, sort of wrapped around this 3/4 ring of ferrite, appears to be the wireless charging coil. And it's tiny and not a complete coil. I would have thought that would make it really inefficient, but they clearly make it work. At the bottom you can sort of see those holes, those perforations which go through to the strap for that accessory port, which, if I rotate these to be actually the same orientation, that might be helpful, which is this little connector here. You can see it's 5 pins, so I think they were talking about accessories like a strap with batteries built in it so you could extend the battery life. I don't know if any came to market that were legitimate. I think they were non-Apple licensed ones that sort of came and went slightly, but again, I think they dropped that port on later Apple Watches. We've got the crown, which, despite my best efforts, is still attached. I'm pretty sure that machining on the inside is for optical encoding, and not in like a scroll wheel type method, more like a one-axis optical mouse kind of thing. So that ground or textured shaft is kind of watched by almost a miniature camera, which then measures the rotation up and down, but with no physical friction. So other than the gasket wearing out, which is waterproofing, and I think also gives it the crown that sort of resistance, there's nothing on the mechanism that will actually wear out, which is kind of cool. And lastly on there, you just have the connector, which connected all the biometrics and the charger back to the motherboard. You've got the haptic engine, which is my nemesis for being magnetic like it is. I mean, aside from the fact it's got a motor in it, I wonder if they will using this to help the charger stay on, because that magnetically attaches, doesn't it? Obviously we've got digitizer and bonded display. It's fairly low resolution in terms of overall pixels, but high density. So, you know, on a screen that size on the smartwatch, you really don't need anything much more than sort of 340 by 340 or whatever suits your aspect ratio. It's not like you're going to be watching a film on it like this. So it's decent pixel density, low total resolution, if that makes sense. And again, we've got that 1.31 watt hour battery. We had a series of little lots and lots of screws. I mean, that is a huge amount of screws for such a small device. And to me, it really was reminiscent of the iPhone 3GS. Just the total screw counts and how they were, you sort of had to be a hand contortionist to get some of them in. And we had this little antenna, which was right at the top of the wrist. And there were a couple of other sort of grounding points and things on there, but the main thing was that sort of coax connector, which gave it away. And then finally the motherboard. I mean, just the sheer number of ribbons and connections and things going on up here is amazing. So in this corner, you've got the crown, and those two little points up here, this sort of little black box with two black shiny bits, I think that's the optical sensor for the crown. So one of those will be like an IR illuminator, and the other will be like a 60 pixel IR camera. So that will just be like I say, like a one-dimensional access out of a mouse, an optical mouse. This big thing still adhered to the bracket is actually the tactile push from the crown. Got the connector here, which connects to the Taptic engine. What's the other connector on there? Oh, the battery connector as well, so the battery and Taptic engine. On this side up here, we have the speaker, which is, again, quite magnetic. Down here, we've got the microphone assembly. At the bottom, we've got that weird accessory port, and then 3 ribbons which connect to the back of the display, 1, 2, 3. So that's all there is to see, which on the surface doesn't sound like much, but that's a staggering amount of miniaturization to fit all that onto this tiny little PCB, which is maybe 25 millimeters by 20 millimeters, sort of an inch by 3/4, that kind of ballpark. And on the back side, which has got the system on a chip and everything, it's all soldered closed RF shielding, I'm afraid. I could destructively get that open, but to see the top of the chip kind of feels a bit gratuitous and not really worth it. I think I might save that for a publicity photo that I have no doubt I'll be able to find that just showed I think they called it the W2 chip in this version of the Apple Watch. Other than doing some close-ups on the microscope, I think that's about all we're going to see for this teardown, which is really cool to see how differently this is built to the Garmin watch. I have to say, because I also have a TicWatch Pro, and I noticed the Garmin watch and the TicWatch Pro all open from the back with screws and like a stainless steel backing plate. So that's at least 2 Android Wear or Wear OS devices that open from the back, whereas Apple have chosen to come from the front under the screen, which is, yes, the screen was already broken, but I've definitely made it worse getting it out, and I'm not sure how easy it is to get the glass off of one of these without damaging it in some way. And that's part of Apple's trademark. They're kind of, we don't care about repairability, we're giving more credence to the aesthetic, and yes, to some degree the waterproof rating, but Garmin watch was waterproof, that survived. Well, I'm really glad that this watch got sent to me. I think it's been a very interesting and challenging teardown, thank you. But if you have an idea for a teardown you'd like to see, don't forget to let me know over the Element 14 community. Thank you so much for watching, and I hope to see you next time.